I'm sure marami na sa inyong nakakita ng comic strip na katulad nito. As we proceed with our lessons regarding this topic, makakita kayo ng iba't ibang mga variations itong comic strip na to at makikita natin, hopefully, kung paano mas nag-i-improve yung joke dito sa comic strip na to as we look at the different versions. This video series is about thermochemistry, and we will start with part 1 wherein we would define some terms and conventions that we will be using all throughout these chapters. Yung reference pala na ginamit ko dito while making these PowerPoints is yung ating grade 9 chemistry textbook, which is Atoms First by Burge and Overby, at kasama din yung reference na Chemistry, the Molecular Nature of Matter and Change by Silberberg, which is the grade 10 textbook. So, thermochemistry belongs under a bigger umbrella or branch of science, which is what we call thermodynamics. Thermodynamics is a study of energy and its transformation. Kung nag-physics na kayo, baka narinig nyo na to or maririnig nyo to in your future lessons in physics. At itong thermodynamics ay isa dun sa mga science topics kung saan mag-overlap talaga yung discussion ng chemistry and physics. However, kapag dinidiscuss natin itong thermodynamics in terms of chemistry, meron tayong certain conventions na different from what the conventions that physics is using. Take note that kapag yung physics class ang pinupuntahan ninyo, you use the physics conventions. While if you're taking chemistry class, you stick with the conventions used in chemistry. Anong mangyayari kapag nalito-lito tayo dyan? The concept is still the same. However, some of the signs of the values that you'll be calculating or using in your computations might be different if you mix up the conventions. So, yun lang ang tatandaan ninyo. We're in chemistry and yung mga conventions na ituturo dito, particularly the signs and yung perspective or point of view kung saan tinitignan yung flow of energy will be different than that of sa physics. Sometimes. Pero minsan may mga pagkakapareho din. So, why study energy and energy changes? From previous lessons, napag-aralan na natin that matter can undergo physical and chemical changes. Isang common example niyan ang lagi nating na-experience in everyday life, yung melting ng ice. And we can actually write it in terms of an equation, just like this. H2O, the phase or state is solid, magiging H2O na liquid. On the other hand, kapag meron naman tayong chemical change, meron tayong bond breaking and or bond forming, an example of which is kapag nagko-combine ang hydrogen gas and oxygen gas to form your water molecule. At syempre, para mabalance natin yan, you add the corresponding coefficients to make it balance. In each of these cases, merong energy involved in the change. Energy, in the form of heat, must be supplied in the first equation, so triangle, para mag-undergo ng change from solid to liquid yung ating H2O molecules. On the other hand, dun naman sa explosive combination ng ating hydrogen gas and oxygen gas, nagre-release siya ng heat. Kaya naman, kapag kunwari pinapaapoy natin ng mga bagay-bagay, we feel that it becomes hotter. Dahil nagre-release yung chemical reaction natin ng energy in the form of heat. In fact, every change that matter undergoes is accompanied by either absorption, tulad nung nasa first equation, or release of energy, tulad nung nasa second equation. Dito sa lessons natin, mag-focus tayo dun sa energy changes na na-associate natin with physical and chemical processes. Dito na papasok yung study of science or thermodynamics which deals with the heat involved in chemical and physical changes, which is termed thermochemistry. Bakit ba masyadong paimportante itong si thermochemistry at meron pa siyang sarili niyang sub-branch of thermodynamics? Marami sa mga chemical reactions na kini-carry out natin either in the lab, in the industry, etc., ay ginagawa natin for the purpose of using the associated energy change rather than for the purpose of obtaining yung products ng reaction. Isang example ng chemical reaction na tinutukoy ko ay yung pagbuburn natin ng fuels. Kaya natin binaburn itong mga fuels na to such as methane, just like in the equation above. Ginagawa natin sila dahil gusto nating makuha yung thermal energy na napoproduce nila. At ayaw natin yung products na napoproduce nitong ating chemical reaction na to, which is carbon dioxide and water. Particularly because alam natin ang carbon dioxide ay isang greenhouse gas at kapag marami tayong nare-release na greenhouse gases in our atmosphere, mas napapabilis yung climate change at yung global warming, which is very detriment to all life living on Earth. Pero bago tayo mag-proceed, i-differentiate muna natin itong mga terms na ginagamit natin para as we go on with our lesson, hindi na tayo malilito masyado sa kanila. Ano ba ang difference ng thermal energy at ng heat? Basically, we define heat in terms of the thermal energy at kung paano nagfo-flow yung thermal energy na yon doon sa ating different types of matter as it changes. Technically, heat is the transfer of thermal energy between two bodies that are at different temperatures. Although the term heat by itself implies transfer of energy, madalas kinaklarify pa natin siya more kaya ginagamit natin yung term na heat flow. Although when you think about it, it's actually redundant. Meaning, kapag tinutukoy natin yung heat flow, we look at energy absorbed or the energy released. At nangyayari itong energy absorption or energy release kapag nagkakaroon ng changes yung matter as it goes through the process of undergoing any change like physical or chemical change. To analyze energy changes associated with physical and chemical processes, we must first define the system. Ano ba yung system na yan? Yung system ay yung part ng universe na gusto nating pag-aralan. Kunwari, meron tayong chemical reaction, yung system natin ay yung mga reactants sa chemical reaction na yun. Depende sa inyo kung gaano kaliit, or gaano kalaki, or gaano kalawak yung scope ng system na gusto nyong pag-aralan. Of course, mahirap na pag-aralan lahat ng nasa universe, kaya kumukuha lang tayo ng part na yun para mas madali nating maintindihan kung ano yung mga processes or changes na nangyayari dun sa gusto nating pag-aralan. After you have defined the system that you're interested in, everything else outside of that system constitute what we call the surroundings. At kapag pinagsama natin lahat ng part ng system mo at lahat ng outside of that system, which is our surroundings, then you have the universe. Okay, para mas malinaw, let's take a look at a specific example. So, tingnan natin yung isang common example na na-encounter natin during your previous lessons. This is an example of a double displacement reaction. Specifically, meron tayong acid at meron tayong base. This is a neutralization or acid-base reaction na magpo-produce ng salt at neutral species natin, which in this case is water. Kapag dinefine natin kung ano yung system dito sa reaction na to, kung gusto natin siyang pag-aralan, the system would be those participating in the chemical reaction, or to put it simply, the reactants. In this case, the HCl and the NaOH, which can be found here in the blue part of our Erlenmeyer flask, yung liquid part sa loob. Everything else, including yung box, yung lalagyan, kung lalagyan nyo man yan ng steering rod dahil gusto nyong haluin, Kung nandiyan yung jowa nyo sa labas, nanonood habang nag-experiment kayo, lahat yan ay part ng ating surroundings. And pag pinagsama natin yung ating system and the surroundings, that is the universe. Take note that sa pagkaka-define natin ng system dito sa example na to, which is the reactants, hindi lahat ng nakikita nyo dyan sa liquid part na yan ay part ng system. Nalito na tayo. Okay, let's explain. Since ang nagre-react lang ay yung HCl, yung H, yung Cl, yung Na, yung O, at yung H, sila lang yung ating system. Aling yung part ng liquid na to na hindi kasama dun sa system? Take note that this is an aqueous solution, which means our reactants are actually dissolved in a solvent, which is water. In this case, yung water natin ay hindi part of the system, but instead it is part of our surroundings. Again, depende sa kung ano yung gusto nyong pag-aralan, yung pagkaka-define kung gaano kalawak o kaliit yung boundaries ng system ninyo. In this case, since we're only concerned with the reaction between H+, Cl-, Na+, and OH-, then the water, which is acting as a solvent, is not a part of the system. O diba, ang hirap ng buhay. Depende talaga sa inyo kung anong gusto nyong i-define. Bakit ba natin pinapahirapan ang buhay natin? Why is it important to define the relationship between the system and the surroundings? Simply put, energy flows from one point to another. Ibig sabihin, yung definition or defining the direction of the flow is vital to accurately describing and understanding the changes that happen in the system that we are concerned with. In chemistry, ang reference point palagi natin ay yung system na ino-observe natin, which is not always the case in physics. Okay? So, laging dito, medyo self-centered tayo. Ang system lang lagi ang point of reference. Now, let's define some units that we will be constantly using all throughout this video series. Yung una ay yung SI unit for energy, which is the joule. At ang abbreviation niya ay big letter J. If we expand the unit, 1 joule is equal to 1 Newton meter, and that is equal to 1 kilogram meter squared per second squared. It's important, especially if you're going to have to make quick calculations at hindi nyo memorize yung mga formula, it's important that you understand what units were combined to come up with this specific unit. Kasi, importante na skill sa chemistry na marunong ka ring mag-cancel at mag-dimensional analysis. Another unit that you might encounter is the calorie. So baka naririnig-rinig niyo yan sa inyong mga ate, kuya, nanay, tatay, at kung sino mang mga shonders na nagda-diet. Calorie, nagbilang ng calories para daw pumayat. So calorie is also a unit of energy, and it is designated with a small c, cal with a small c. 1 calorie is equal to 4.184 joules. This is not a calculated number. This is actually an exact number. So, yan ang conversion natin ng calories to joules. However, please do not be confused with another quote-unquote unit of calorie, which is cal with the big C. 1 cal with a big C is actually equivalent to 1 kilocalorie, which is 1,000 calories. Usually ngayon, mas ginagamit na yung kcal, pero in old times kasi, no mga wala pa tayo sa mundo, iniisip pa lang tayo ng mga magulang natin. Ito yung ginagamit nilang convention. So, actually maraming mga labels dun sa likod ng mga food and beverages na mabibili ninyo, mali yun nakalagay, big cal yun nakalagay. So magugulat na lang kayo, bakit sobrang daming energy naman itong C2 na to, itong junk food na to, VCAT na to. That is because minsan nami-mislabel itong mga pagkain na ito. So kayo, wag kayong magkakamali kapag nagsusulat ng unit for calories. And to give you an idea on how big a joule is, on the right is a scale kung ano ba yung equivalent ng certain amount of joules in terms of yung energy na na-experience natin in everyday life. So when we do calculations later and you want to understand, okay, ano ba tong 3 joules? Malaki ba to? Maliit ba to? You can go back to this slide and you can look at yung comparison ng mga nakakalculate natin na values dun sa actual observed na magnitude niya sa totoong buhay, sa na-experience natin in everyday life.